Late at night on December 18th, 2023, the Icelandic citizens of Grindavík experienced their worst nightmare. After weeks of earthquake-filled suspense, a volcanic fissure opened 4 kilometers northeast of town and began spewing lava fountains 100 meters tall. Luckily, the molten rock flowed elsewhere, narrowly avoiding the small fishing town. But Iceland wasn't willing to leave Grindavík's fate to chance again. To prepare for future eruptions, the government began exploring how to control these red-hot rivers of destruction. Steering a lava flow is about as difficult as it sounds. Molten rock, which we call magma when it's underground, and lava when it breaks through the Earth's surface, can reach temperatures of roughly 1,200 degrees Celsius. That's over 4 times hotter than the maximum temperature of a standard kitchen oven. Now imagine that heat radiating from several square kilometers. At this temperature, lava ignites or melts most things in its path. And since it's as heavy and dense as the rocks it's composed of, its flow is almost unstoppable. Fortunately, there are 2 factors that make lava flows a little easier to handle. First, while it can take decades to cool completely, lava becomes solid and still after cooling to roughly 600 degrees Celsius. This process typically happens on its own in just a few hours, unless an ongoing eruption is fueling the flow. Second, lava generally flows at a rate of less than 1 kilometer per hour. This slow speed gives people time to evacuate and respond with various solutions, though some ideas are better than others. One questionable strategy, championed by the first director of the Hawaii Volcano Observatory, Thomas Jagger, was to fight lava with bombs. When the 1935 eruption of Mauna Loa threatened the Hawaiian town of Hilo, he convinced the US Army Air Corps to drop 20 bombs on the flowing lava to disrupt its path and stop its advance. 6 days after the operation, the lava did stop flowing, prompting Jagger and the US Air Force to label their mission a success. But today, most volcanologists consider the timing to be a coincidence. Since lava flows like a liquid, experts believe the bombs merely displaced it temporarily, forming a crater which flowing lava then refilled. Perhaps the more obvious solution is to cool lava with water. Due to lava's low heat conductivity, this requires an enormous amount of H2O. But that didn't stop the Icelandic government in 1973, when the Eldfell volcano erupted and lava began streaming towards the Heimaey harbour. They began a highly coordinated effort to pump 6 million cubic meters of seawater onto the lava flow. That's enough to fill 2,400 Olympic-sized swimming pools. At the peak of their efforts to manage this 6-month-long eruption, 75 people worked in shifts around the clock, spraying down each actively advancing area for roughly a full day to stop its flow. This approach did save the harbour, but it could only work in a place with access to this much water. Regions further from the coast require different defences, like large earthen barriers. Typically made of materials like sand, dirt, or volcanic gravel, these barriers can divert lava flows away from populated areas. For example, when Italy's Mount Etna erupted in 1983, workers used 750,000 cubic meters of material, the equivalent of 25,000 truckloads, to erect 4 large barriers. The people of Grindavík took a similar approach after the 2023 eruption, building 25-meter-high barriers that successfully diverted lava from multiple eruptions. Since the diverted lava raises the ground level as it flows, these barriers had to be raised between each eruption. But the advantage of this approach is that it allows regions to build up defenses between flows instead of during them. Scientists are still working to better predict exactly where lava flows will emerge, what direction they'll travel, and just how much lava an eruption will produce. But once they figure it out, engineers can leverage existing strategies to protect communities from these otherwise awe-inspiring eruptions. Ready to keep learning? Watch these videos to either challenge what you think you know or learn more about what you don't. Subscribe and stay curious.
Let's roleplay.